Imagine this. You're standing on one side of a mountain, surrounded by dense forests, mist drifting between tall trees, and rivers rushing through deep green valleys. The air feels cool and damp, and clouds cling to the slopes above you. Then you cross the mountain, and suddenly, everything changes. The air becomes dry, the ground turns dusty, the forests disappear. Instead of lush valleys, you see barren hills, dry grass, or even desert stretching toward the horizon. How can the same mountain create two completely different climates just a few miles apart? The answer is one of the most fascinating and powerful forces shaping our planet. Welcome to Science Meets Adventure, the channel where we explore the incredible science behind the world's most fascinating landscapes. Today, we're uncovering the secret behind rain shadows and how mountains quietly decide where forests grow, where rivers flow, and where deserts begin. To understand rain shadows, we need to start with something invisible: air. More specifically, moist air. Over oceans and large bodies of water, air absorbs water vapor. Think of it like a giant sponge drifting through the atmosphere, slowly filling with moisture as it moves across the sea. Winds carry this moisture across continents, but eventually, that moving air runs into something enormous, a mountain range, and mountains act like giant walls in the path of the atmosphere. Air can't pass through rock, so it has only one option. It must rise. As moist air climbs up the side of a mountain, it begins to expand and cool. And cooler air can't hold as much water vapor as warm air can. So the invisible vapor begins to condense. Clouds start to form. At first, they're thin and wispy, but as more moisture gathers, the clouds grow thicker, darker, heavier. Eventually, the sky opens. Rain begins to fall, sometimes gentle rain, sometimes powerful storms. This process is known as orographic precipitation, a scientific term that simply means rain created when air is forced to rise over mountains. That's why the side of the mountain facing the incoming wind, known as the windward side, is often incredibly lush. Forests grow thick and green. Rivers flow down steep valleys. Waterfalls carve their way through cliffs. Entire ecosystems flourish because mountains force the atmosphere to release its moisture. But the story doesn't end at the top of the mountain. After dropping most of its rain, the air finally reaches the summit. Then it begins to descend down the other side. And something interesting happens again. As the air moves downward, it warms up. And warm air can hold more moisture. So the clouds disappear, the sky clears, humidity drops, and rain becomes extremely rare. This dry region on the far side of the mountains is called a rain shadow. And rain shadows can transform entire landscapes. One of the most dramatic examples on Earth lies in Asia, the Himalayas. These mountains form one of the most powerful climate barriers on the planet. Moist air from the Indian Ocean moves northward during the monsoon season and crashes into the towering wall of the Himalayas. As the air rises along the southern slopes, it releases enormous amounts of rain. That's why regions like Nepal and northern India are covered with lush forests, fertile valleys, and powerful rivers fed by seasonal storms. But cross over the mountains to the north, and the world changes. Suddenly, you enter the Tibetan Plateau. Instead of monsoon rains, you find vast dry plains, cold deserts, and windswept landscapes stretching across high-altitude valleys. The Himalayas squeeze most of the moisture from the air before it ever reaches this region. The result is one of the highest and driest regions on Earth. Now let's travel to South America. The Andes Mountains stretch more than 7,000 kilometers along the continent's western edge, forming the longest continental mountain range in the world. Moist air from the Amazon basin rises along the eastern slopes of the Andes, producing heavy rainfall that feeds some of the most biodiverse rainforests on the planet. But once that air crosses the peaks and begins descending toward the Pacific coast, something extraordinary happens. The landscape becomes the Atacama Desert, one of the driest places on Earth. In some parts of the Atacama, weather stations have recorded years without measurable rainfall. Scientists often describe parts of this desert as the closest environment on Earth to the surface of Mars. And one of the main reasons it exists is the powerful rain shadow created by the Andes Mountains. You don't need massive mountain ranges to see this effect. Even smaller ranges can create dramatic rain shadows. A perfect example appears in the Pacific Northwest of the United States, the Cascade Mountains. Moist air from the Pacific Ocean moves inland and slams into the western slopes of the Cascades. This side of the mountains receives heavy rainfall, creating thick evergreen forests, moss-covered landscapes, and famously rainy cities like Seattle. But drive just a few hours east across the mountains, and the environment transforms. Forests fade into open grasslands. Grasslands give way to dry shrubland. Parts of eastern Washington receive less than a quarter of the rainfall that the western side does, all because the Cascades have already squeezed most of the moisture out of the air. Rain shadows don't just shape scenery, they shape life. On the wet side of mountains, dense forests support incredible biodiversity. Rivers provide fresh water, soil stays fertile, and ecosystems flourish. But in the rain shadow regions, life adapts to dryness. Plants evolve to store water. Animals survive with limited resources. And human agriculture often depends on irrigation rather than natural rainfall. In many places around the world, a single mountain range determines whether land becomes farmland, forest, or desert. For hikers, climbers, and travelers, rain shadows create some of the most dramatic journeys imaginable. Imagine trekking across a mountain range. You begin your hike in a humid forest filled with birdsong, moss-covered trees, and mist drifting through the valleys. As you climb higher, clouds wrap around the peaks, and cool air flows down the slopes. Then you cross the summit, and slowly the world begins to change. Trees grow smaller, the air becomes drier, the ground beneath your boots turns dusty. By the time you descend into the valley on the other side, the landscape looks completely different. It feels like walking from one climate zone into another, sometimes in a single day. And that's the quiet power of mountains. They don't just shape the land, they shape the movement of air, water, and life across the planet. Some of the world's greatest forests, and some of its driest deserts, exist simply because mountains stand in the path of the wind. So the next time you see a mountain range rising on the horizon, remember this. Those peaks aren't just dramatic scenery, they're giant climate machines, silently deciding where rain will fall and where it won't. If you enjoy discovering the science behind Earth's most incredible places, don't forget to like, share, and subscribe to Science Meets Adventure for more journeys where science meets exploration. And until the next adventure, keep exploring.